Welcome back. So in this video segment we'll be solving all the problems in the unit areas related to a circle. The third exercise, a very interesting set of problems here. So before we move on, make sure that you do like, share and subscribe and press the bell icon to get notifications of further uploads. So in the first problem, we have the line RQ which passes through the center. So this becomes the diameter of the circle. And then there is a chord PQ of length 24 centimeters. And then PR is 7 centimeters. We have to find the area of this shaded region. Now since this is a chord in the region of the semicircle, this is at right angle. So angle P, or we should say angle RPQ, is 90 degrees. So this forms a right angle triangle. So therefore RQ square equals PR square plus PQ square. So which is 7 square plus 24 square. So RQ is nothing but root of 7 square plus 24 square. So we get the value of QR as 25 centimeters. Now QR is the diameter. So therefore the radius of the circle R is 25 by 2 centimeters. So that is the radius. So now we need to find the area of this shaded region. So the area of the shaded region is nothing but the area of the semicircle and then minus the area of the triangle. So area of the semicircle. So area of semicircle is nothing but half pi r square, which is 25 by 2 the whole square. So we get the value as 245.54 centimeters square. So this is the area of the entire semicircle. And then we find the area of the right angled triangle. So area of triangle PRQ, which is equal to half into the base is 7 into the height is 24. So which is 7 into 12. So we get 84 centimeters square. So area of shaded region is nothing but the area of the semicircle, which is 245.54 minus 84, which gives us 161.54 centimeters square. Right? So of course this is a very small region which is of course neglected here. So this is the area of the shaded region. Next, the second problem, we need to find the area of this shaded region. So there are two concentric circles with center O. So the radius of the first circle is 7 and the radius of the second circle is 14. So we need to find the area of this shaded region. So what do we do? Find the area of this sector OAC minus the area of the sector OBD, and then we get the area of the shaded region. Right? So now area of the sector AOC is 40 by 360. So the angle here is 40 degrees into pi into r square, which is 14 square. And we get the value as 68.44 centimeters square. Next, area of OBD is 40 by 360 into pi into r, which is 7 square. So we get the value as 17.11 centimeters square. So area of the shaded region. So area of the shaded region is 68.44 minus 17.11. So we get the value as 51.33 centimeter square. So next, problem 3, there is a square. ABCD is a square. and the side is 14 centimeters. And we need to find the area of the shaded region if you have two semicircles which touch at point P. Now this is a square, so therefore the radius of this semicircle would be 7 centimeters. So this is one semicircle of radius 7 and this is another semicircle of radius 7. So to find the area of this shaded region, you find the area of the square minus area of the circle. This is half a circle, this is another half circle. So combined, it becomes the area of the circle of radius 7. So therefore, area of the square ABCD is 14 square and area of the circle is nothing but pi into r square, which is 7 square. Right? So therefore we get the value as, so this is 196 and this is 154. So 196 minus 154 gives a value of 42 centimeters square. So this is the area of the shaded region. Next we need to find the area of the entire shaded region. So there is an equilateral triangle of side 12 centimeters and there is also a circle of radius 6 centimeters. So let's first find the area of the triangle. The area of the triangle ABO is root 3 by 4 into the square of the side, which is 12 square. So this is the area of the triangle, which is root 3 into 36 centimeters square. Okay, so now we need to find the area of the shaded region of the circle. So this area, if I find the area of the entire circle minus the area of this sector, so this is 60 degrees because AOB is an equilateral triangle. So area of this part of the circle would be area of the shaded circle would be area of the entire circle, which is pi into r square minus this region. So this region which has to be subtracted because it's already included here in the area of the equilateral triangle. So it's going to be 60 by 360 into pi 6 square. So that gives us the area of the shaded circle. So we get the value as 660 by 7. So the area of the entire shaded region would be the sum of these two, which is root 3 into 36 plus 660 by 7 centimeter square. Next, fifth one. There is a square and then on four corners we have these circles, a quarter of a circle of radius 1 centimeter. So the radius is 1 centimeter. And also we have another circle inscribed with a diameter of 2. So the diameter is 2 centimeters. So radius again is 1 centimeter. And this is a square. The square is of length 4 centimeters. So we need to find the area of the shaded region excluding the circle and these 4 quarter circles. Right? Now the area of this is a circle of radius 1 and this is 1/4 of a circle. So when I add these 4, I get another circle, the area of one complete circle again of radius 1. So if I add these two, so area of 2 circles would be 2 into pi r is 1 square. Right? So now I find the area of this entire square. So area of square is 4 square. I need to find the area of the shaded region would be area of the square minus area of these two circles. So area of the shaded region would be 16 minus 2 pi centimeter square. So this is 68 by 7 centimeters. Problem 6. There is a table cover which is circular, having a radius of 32 centimeters, and a design is formed. So you have the design here, and in between there is an equilateral triangle ABC. So we need to find the area of the design. Right? So we have to find the area of the circle minus area of this triangle. So area of the circle is going to be, so we have the area of the circle, which is pi into 32 square, and I need to find the area of this equilateral triangle. So to find the area of the equilateral triangle, we need to find the side. So extend this line to intersect the line BC at D, at right angles. Right? So the point D divides BC into two equal halves. So therefore, BD is equal to DC, and OA happens to be the radius here. Right? So therefore, so we know that in such a situation where we have an equilateral triangle and we have a line drawn from A perpendicular to BC, which divides the line BC into two equal halves, we know that 2/3 AD is equal to the radius of the circle, which is 32, or AD is 3/2 times the radius. So therefore AD is 3/2 into 32. So we get the value of AD as 48 centimeter. So we have AD, which is 48, and then DC is half. So given AD is 48, so now let's find one of the sides. So we know that AB square equals AD square plus BD square. But what is BD? BD is nothing but BC by 2 or AB by 2, because all the three sides are equal. So I can write this as AD square plus BD is nothing but AB by 2, the whole square. Right? So therefore we have, I bring this to LHS, so we get AD square into 3/4, because this becomes 1/4, equals AD square. So AD is 48, the square of that, which is 3072. So therefore we get, if we calculate, we get the value of AB as 32 into √3. So now we can find the area of the triangle. So area of triangle ABC is √3/4 into AB square. 32 into √3 the whole square, so which gives us a value of 768 into √3 centimeters square. So we need to subtract these two. So area of the shaded region equals, we have pi into 32 square, which is 22528 by 7 minus 768 √3 centimeter square. So this is the area of the shaded region. The next problem, problem 7, we need to find area of this shaded region here. Now ABCD is a square, so AB is 14, and hence the radius of the circle would be 7 centimeters. Okay, so to find the area of this shaded region, find the area of the square minus area of these quarter circles. So if I add up these 4 quarter circles, it becomes area of one full circle of radius 7. So let's find area of ABCD, which is 14 square centimeters. Yeah, 14 square centimeters. And then to find the area of these circles, quarter circle added together is one full circle, so it is pi into r square, 7 square. So which gives us 154 centimeter square. So area of shaded region is, subtract these two. So 14 square, so area of the shaded region is 14 square is 196 minus 154, which gives us 42 centimeter square. So next there is a track where on either sides is a semicircle. The distance between the two parallel line elements is 60. So these are the two inner elements, the distance is 60 and the width of the track is 10 meters. So I have 10 meters here, 10 meters here. So this distance is also 60 meters and this distance would be 60 plus 10 on either side, so that would be 80 meters. And these are the two semicircles. So the diameter of the inner semicircle is 60, so the radius of the inner semicircle, so I call it as R1, is 30 meters. And the radius of the outer circle would be 80 by 2, which is 40 meters. Right? So now we need to find the distance of the track along the inner edge. So what is this distance? So this distance is 106 plus 106 plus the circumference of the inner circle, which is 2 pi r. So distance of the inner track, distance of the track along the inner edge would be 106 plus 106 plus, this is half the circumference plus half the circumference, which is going to be 2 pi r, which is 30. So this gives us a value of 2804 by 7 meters. So this is the distance along the inner track. So now we need to find the area of the track. So the area of the track is, so to find the area of this rectangle, so it's going to be 106 into 10 plus 106 into 10. So that's going to be 106 into 10 into 2, which gives us 2120. So with this we have found the area of this part of the track. So this part of the track and this part of the track. So now we need to find the area of this part. So to do that, find the area of the outer circle, because you have half the circles on either sides minus the area of the inner circle will give me these two areas, right? So therefore we have the area of the outer circle minus area of the inner circle. So area of the outer circle, that is circle 2, minus area of the inner circle, which is circle 1, which is pi 40 square minus pi 30 square, and I need to add it with 2120. So this is pi into 40 square minus 30 square, which gives me 700. So the total area would be 2120 plus 700 pi, which is 4320 meters square. So given problem 9, we need to find the area of this shaded region, right? So given OA equals OD, because it forms the radius, so therefore OA equals OD equals 7 centimeters, which has been given. So let us find the area of this entire circle. So area of circle 1, which is the bigger circle, is pi into r square, which is 49 centimeters square. So now we need to find the area of this smaller circle. So since this is 7 centimeters, the radius of this small circle would be 3.5. So area of circle 2 is pi into 3.5 the whole square. So that gives the area of the smaller circle. Now we need to find the area of this triangle ABC. So area of triangle ABC is half into base into height. So half into the base is AB, which is 14, into the height, which is OC, is the radius 7. So 14 into 7, which is again 49 centimeters square. So this is 7 into 7, which gives us 49. So to find the area of the shaded region, let us find the area of this semicircle. Area of this semicircle is pi into 49 by 2 minus this triangle, which is 49, area of the triangle, gives me the area of this shaded region, and I need to add the area of the smaller circle, right? So this area plus pi into 3.5 the whole square would give me the area of the shaded region. So if we calculate, we get the area as 66.5 centimeters square. Okay, so make sure that you do the calculations correctly. This is area of this half circle. From this half circle, I have subtracted the area of the triangle, so which gives me area of these two shaded regions. And then I need to add the area of the smaller circle. So finally, I get 66.5 centimeters square. So next, we need to find the area of this shaded region, where the area of the triangle ABC is 17320.5 centimeters square, where ABC is an equilateral triangle, and ABC form the center of the circles, right? So ABC form the center of the circles. So this is the radius. So if I find the side of the equilateral triangle, the radius of the circle will be half its side. So therefore, root 3 by 4 into a square equals 17320.5. So we need to find the distance, which is the side. So we get a as 200 centimeter, right? So if we do the simplification, this into 4 divided by root 3 and take the square root, we get 200. So therefore, the radius of the circle is 100 centimeter, right? So we know the area of ABC. The area of ABC is this. From that, we need to subtract the area made by these circles. So this is at an angle 60, this is at an angle 60, and this also is at an angle 60. Right? So when we calculate the areas made by the circles, which map onto the equilateral triangle, it is nothing but half the area of the circle. So 60 plus 60 plus 60 is 180. So this is half the area of the circle. So therefore, the area of half the circle would be pi into r. R is 100 square into 1 by 2. So area of ABC minus area of this. So this is 15700 centimeters square. So area of the shaded region is 1732.5 minus 15700, which gives us 1620.5 centimeter square. So next, there is a square handkerchief with 9 circular regions and the radius is 7 centimeters. So we need to find the area of this shaded region. So we need to find the area made by these remaining portions. So the radius is 7, plus 7 is 14. So I get plus 14 here, the diameter of the second circle, and plus 14 diameter of the third circle, because all the circles touch each other. So this side of the square, let me call that as A, is 3 into 14, which gives me a value of 42. So if I call this square as ABCD, so area of ABCD is 42 square. So that gives a value of 1764. Next, we need to find the area of these 9 circles, each circle having a radius 7. So area of one circle is pi into r square, which is 49. So now I have 9 circles, so I multiply this by 9. So I get the area of all these 9 circles. So I need to subtract 1764 minus this to get the area of the shaded region. So area of the shaded region is 1764 minus pi into, so the value what we get is pi into 49 into 9. So we get the remaining value as 378 centimeters square. So that is the area of the shaded region. Next, problem 12. We need to find the area of this shaded region where OD is 2 centimeters and the radius of this circle, quarter circle, is 3.5 centimeters. So first let us try to find the area of the quarter circle. So area of the quarter circle, which is OBCA. So it is 1/4 the area. So I can write it as 1/4 into pi into r, which is 3.5 the whole square. So we get it as 9.625 centimeters square. Okay, so this is 1/4 the circle. So next, to find the area of the shaded region, I need to find the area of this triangle. So area of the triangle BDO is half into, now this is the center of the circle and this happens to be the radius, so this also is 3.5 centimeters. So it is half into base, which is 3.5, into height, which is 2. So we get the value as 3.5. So therefore the area of the shaded region is 9.625 minus 3.5, which gives us 49/8, right? Or we get 6.125 centimeter square. So next, problem 13. A square is inscribed within a quarter of a circle where OA is 20 centimeters. So find the area of the shaded region. So this is a square. So we can find the area of the square, which is OABC, which is 20 square, which is 400 centimeters square. Now since this is a square, this length, that is AB, is also 20, and we can find the hypotenuse. So this angle is 90 degrees. OB would be the radius of this circle. So R equals 20 square plus 20 square, the whole root. So which gives us root 800. So now find the area of this quarter circle. So area of this quarter circle, that is OQBP, is 1/4 pi r square. R square is 800, right? So we get the value as pi into 200. So area of the shaded region is the area of quarter circle, which is pi into 200, minus area of this square, which is 400. So we get the value as 228 centimeters square. Very simple problem. So problem 14, we need to find the area of this shaded region where we have the radius OC is 7 centimeters and OB is 21 centimeters, and this angle, which is common, is 30 degrees. So find the area of this sector, right? So area of the sector AOB is 30 by 360 degrees into pi r square, which is 21 square, and area of OCD equals 30 by 360 into pi r square, which is 7 square, right? So we need to subtract these two. I need to subtract these two. So when I do that, we get the value as 308 by 3 centimeters square, right? So subtract these two, the area of this AOB minus area of OCD, when we subtract we get 308 by 3 centimeters square. So this is a very simple problem here. We have ABC, which is quarter of a circle, and BC is joined. And then what is done is another circle is drawn by considering the center of the line B and C. So a semicircle is drawn with BC as the diameter. So we need to find the area of this shaded region. So first let us find the area of this quarter circle. So area of the quarter circle, which is A, B, D, C, this quarter circle would be 1 by 4 into pi. So the radius is 14 square, right? So we get this area as 154 centimeters square, right? So I have got the area of the quarter of a circle. So this is what we have got, the area here, right? So now let us find the area of the semicircle which is drawn with the center here. Let me call this as O. So with the center we have drawn a semicircle, right? So I need to find the length BC so that we can find the radius. So BC diameter is nothing but root of 14 square plus 14 square. So this forms a right angle triangle. This is 14, this also is 14 centimeters, right? So using Pythagoras theorem, BC is nothing but root of 14 square plus 14 square. So we get the value as 14 root 2. So now the radius BO is 7 root 2. So with this as the radius, a semicircle is drawn, right? So we can find the area here. So the area of the semicircle is nothing but 1 by 2 into pi r square, 7 root 2, the whole square. So pi r square, we get the value as 154 centimeters. So now to find the area of this region which is shaded in green, what we do is, now let us only try to find the area of this region. So now if I subtract the area of the quarter circle, so area of the quarter circle is 154 minus area of the triangle which is 98. So therefore I get this region. So from the area of the quarter circle I have subtracted the triangle region, so I get this. Okay, right? So this gives us 56. So this is the area here. So now to this, if I consider area of the semicircle, area of the semicircle is this entire area. So this entire area is 154. So from 154 I need to subtract this region which is shaded in black to remove this entire region. So this area has to be removed, isn't it? So that is 56. So I subtract 56 from 154. So area of the shaded region is 154 minus 56, which gives us 98 centimeter square. So this is a very easy way to understand. So first consider subtracting the area of this triangle from the quarter circle. Then I get this which is shaded in black. Now this region which is shaded in black has to be removed, but when I consider area of the semicircle, it also includes the area which is shaded in black. So therefore from the area of the semicircle which is 154, I subtract the area which is shaded in black, which is 56, to get 98. So I only get this region which is shaded in green, which we need to find. So coming to the last problem, which is 16, find the area of the design between two quadrilaterals of circles of radius 8 centimeters. So we find that each side is 8 centimeters. So problem 16, we need to find the area of the shaded region. So where all the side is 8 centimeters and of course the angle is 90 degrees. So let me call these points as A, B, C, D. Let me join B and D. Right? Now this circle which is drawn from B to D with center A forms quarter of a circle. Right? Now from this quarter of a circle, if I subtract the area of triangle ABD, so what am I doing? So we have this quarter of a circle which is A, B and D. So first find the area of this quarter of a circle. So what do? The area of quarter of a circle which is ABD circle is 1 by 4 into pi r square. The radius is 8 square. So this area is nothing but 1 by 4 pi into 8 into 8. So this is 16 pi. So we get 16 pi here. Now from this, if I subtract the area of this triangle, so area of the triangle ABD, which is half into base is 8, into height is again 8. So we get 8 into 4, which is 32 centimeters. Right? So therefore we get this area. So therefore area of this shaded region on one side is 16 pi minus 32 centimeters square. Now similarly I can find this part of the shaded region which is equal to the area here, what we have found out, isn't it? So the total shaded area is just twice. So the total area of the shaded region. So the total area of the shaded region is just 2 into 16 pi minus 32 centimeter square. Wherein if we simplify this, we get the value as 256 by 7 centimeters square. So it's a very simple problem here. So we consider one at a time. So we consider 1/4 of a circle and from that subtract the area of the triangle. And we find that if I consider the other quarter of the circle and subtract the triangle BCD, we get the same area here. So just multiply this area by 2, we get the area of the shaded region. This completes all the problems given in the last exercise of the unit areas related to a circle. I hope you have followed all the problems which have been explained here. In this exercise, make sure that you keep solving problems, and if you have any doubts and queries, you can always comment or write to me. And thanks for watching. Do not forget to like, share and subscribe and press the bell icon to get notifications of further uploads. And thanks for watching.